Today's video will demonstrate some best practices for adding asserts to a program. Hello, I'm James Helfrich. Asserts are useful tools for finding bugs in programs. There are some places you can place asserts that are really helpful, and some of them not so much. This video will demonstrate several best practices for placing asserts in programs. So what's an assert? It's an checked place in a program representing an assumption the developer thinks is always true. And we really want all of our checks to be valid, reliable, and efficient. So what does this mean? Valid. I want to be able to distinguish between properly functioning code and a bug. Reliable means there's no deviation. There's no false positives and no false negatives. If an assert fires, we know there's a problem. If it doesn't, then there's no problem. And finally, we want it to be efficient. It should take a small amount of effort to add an assert, and it should take the computer a small amount of time to verify it. If all of our checks are valid, reliable, and efficient, then we'll be able to quickly and efficiently find our bugs. So let's take a look at some examples of asserts that are valid, reliable, and efficient, and some that are not. Okay, we are going to go through 4 different examples, each one of increasing level of complexity and difficulty. This first one is an averageGrades function, and this is written in C++. Observe that I have an input array called grades, and I have an input number of elements called num. Now, what I'm going to start with a precondition assert, and this precondition is to make sure that num is valid. So I'm going to assert that 0 is less than num, because I don't want to have 0 elements, and, well, I don't really have an upper bound for num, so I'm just going to have 0 is less than num. Next, I'm going to loop through all possible values. So I'm going to put an assert inside my loop here. And as a rule of thumb, it's always a good idea to use an assert every time we have an index. So I'm going to say assert that 0 is less than or equal to I, and I is less than num. And that's going to ensure that I don't walk off the end of my array on either side. Now, also grades itself might be in an invalid state. So I'm going to assert that 0 is less than or equal to grades of I, and grades of I is less than or equal to 100. In other words, I want to make sure that each grade is also within the valid range. Now, I don't want to include something like assert that sum equals 0. This is the type of asserts we don't want to do. This is not going to catch a bug because I just assign it to 0 immediately beforehand. It's just going to add noise, which is going to make it more difficult to understand the program, and it's going to add unneeded complexity. So this is kind of an efficiency challenge here. Now, at the end here, I like to make sure that I don't crash, that num is not 0. I also want to make sure that sum is positive, and I also want to make sure that the resulting average is going to be within the 0 to 100. So in order to do that, I'm going to create a separate variable called int average equals, one second here. I'm going to compute the average, and I want to do this because I want to assert that the average value is valid before I return. So after I compute average, I'm going to say assert that 0 less than or equal to average, and average is less than or equal to 100. But before I do this, I want to make sure num is 0. So that would give me a crash. Assert num not equal to 0, and assert that sum is greater than or equal to 0. Okay, so I've added 1, 2, 3, 4, 5, 6, 7 asserts for 1, 2, 3, 4 lines of code. That's about right. 2 to 1 is what I expect. This is the typical number of asserts you add for a program. The next example is going to be in Python, and it's going to be a binary search algorithm. We're going to look for a value in an array of values. Okay. I always have a precondition. I want to make sure that my input is correct. So I'm going to assert that type of value equals type of values of 0. I also want to assert that length of, and I better do this after I have a 0 element array, of course. And I want to assert that type of values equals type of, it's a list, because this needs to be a list or I'm not going to be able to find it. Okay. Okay. Here's the type of asserts we don't want to do. I don't want to say assert that I first equals 0, because I just set it to 0. It's not going to really help me with anything. However, I do want to make sure that n is within my set of possible values. So I'm going to say 0 is less than or equal to I, n is less than length of values. Notice that Python allows me to combine both the precondition, the lower bound and the upper bound in one Boolean expression, where C++ that I did before did not. Okay, while I first is less than or equal to I end. So before I do the calculation, I want to assert that that 0 is less than or equal to that 0 is less than or equal to I first, which is less than the length of values. I also want to assert that 0 is less than or equal to I end is less than length of values, because I'm about to assume that those are within the valid range, and I'm going to check it right here. I also want to assert that type of value equals type of values I middle. And the reason why I want to do this, because I want to make sure every element in the array values is the same data type of what I'm searching for. And now technically I could do this precondition up here at the beginning by looping through all elements of the array to make sure that the array is not malformed. Because here's the thing. If the array is malformed, my function is not going to work. And any bugs that I encounter will not be in this function, but in the caller. And making asserts like this in the precondition help the programmer realize where the bug is going to be. And it's not going to be in this algorithm. Okay, end my middle minus 1, first middle plus 1, else return true. And what I could do, I guess, is I could repeat my assert here so that as soon as the assert is the value of I first is calculated, I can check it right away. So I know just to look at the initial value there, and end as well. Okay, there we go. And then finally, value I equal value first. And I'm going to be checking on a first value here. So I need to put my post condition there as well. Okay, that's a good number of asserts. Let's see what we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9 asserts for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code. Yeah, that's about right. Okay, the third example is also in Python. This is a chess program, and here I like to display a chessboard on the screen. This includes the column headers A, B, C, D, E, F, G, as well as the row headers 1, 2, 3, 4, 5, 6, 7, as well as the piece itself, which could be lowercase for white and uppercase for black. Okay, now we're going to start by ensuring that the board is in fact a list. So I'm going to, my precondition is going to say assert that type of board equals type of list, okay? And we also want to make sure that the first array for the board is going to be 8 elements. Assert, so length of board equals 8. If I'm not going to have 8 columns, 8 rows, sorry, then I'm going to have a problem. Next, for each row, I'm going to assert that type board of row is also a list. And I also want to assert that length of board row equals 8. So in other words, each row has exactly 8 columns. And now since I'm about to do an index, I also want to assert that 0 is less than or equal to row is less than 8. All right, now I'm going into my specific columns here, and I'm going to assert that 0 is less than or equal to C is less than 8. And I also want to assert that board row column, what type is it? It better be a character, okay? Now, finally, I want to make sure that each individual element within the board is going to be one of several types. So I'm going to say assert that board row column equals or is in the set of space or lowercase p for a white pawn or uppercase P for a black pawn, or Q for white queen, or capital Q for black queen, or lowercase k for king, or uppercase K for king, or bishop, and do I have one more? Oh, that's right, the knight. Notice how my line is getting to be way too long here, so I'm just going to break it up into several columns. There we go. And this goes all the way out to column 70, so within the border here. Okay, there we go. Now, my last example, I'm not going to do a live demo, but rather I'm going to show just how complicated asserts can be. This is also a game of chess, but now this one is in C++, and I want to execute a move on a board. So I want to assert that the guy I'm trying to move is not a space. The source for my move and my destination are valid positions. I'm not off the board. I want to assert that the board itself is properly set up. Let's see if I can find the code for that. So I'm going to go through every row and column, and I'm going to make sure that each piece is where they think they are and that they're all the correct type. Okay, then for a kingside castle, then I want to make sure that the slot in column 4 is a king, and 5 is a space, and 6 is a space, and 7 is a rook. For a queenside castle, king, space, 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 rook. In other words, there's no point in trying to execute a move if the move itself has not been properly formed. One final thought. Assert placement is a highly personal issue. What we try to do is add asserts catching the types of bugs we, as an individual programmer, tend to add. For an example, if you tend to have off by 1 errors, then have asserts that check for that. If you tend to have errors with passing parameters incorrectly, then add asserts to check that. The more experience you become as a programmer, the better you'll get at adding asserts that will catch your specific types of bugs. You can learn more about placing asserts and the Preventing Bugs with Asserts section of the Asserts chapter of the Software Design textbook.